Hi, everyone. Um, Welcome to this session of the Barana Community Call. Um, I hope everyone's doing well. So let's start with the start by giving us a small intro about the Barana Community Call. Um, so this is a monthly recurring meeting that we are doing uh, by the Barana team and the community. And community call structure is basically we'll be picking a specific feature about a new upcoming feature or existing feature, and we'll explain how it works, do some demonstrations, and basically have an open discussion about it. Um, so there are some links here, so you can find the current agenda by going through the agenda links. And also, if you want to be kept up to date of the community call events that are happening and the information regarding that, you can register to the call by filling up this form, the Notify Me form. And also, you can suggest topics for the team to like talk about, or any topic you would like to like present even. So you can fill this form and send it across as well. So basically today's topic is on serverless and the serverless features we have in Ballerina. So we'll basically go through mainly the function as a service features we have built in Ballerina, and the surrounding functionality that comes with it. Uh, so we'll be talking about two main platforms, AWS Lambda and Azure Functions, and basically go through the functionality, and also like it will be mainly driven by some demonstrations actually. So I'll explain its features while doing some coding, some demos. So of course, if you have some questions regarding the session, you can send in the questions to the chats, respective chat options in your platform, and we'll answer it at the end of the session. And also, you can straight away unmute yourself and talk at the end also to directly present the questions. And also, this session is recorded, so you can revisit it later as well. So let's start with the first option, so that I'm going to talk about. So this is actually the agenda I mentioned. Um, so the first one, we are going to talk about AWS Lambda, and so we'll be talking about the basics first, and also I'll be doing a few scenarios with it, and also I'll go into a workflow scenario with AWS Step Function as well, where I'll be using some lambdas to do some operations. And afterwards, we'll move into issue functions. So let's start with AWS Lambda. So first of all, so this is the view of a simple Lambda function that will define it in Ballerina. So as I mentioned, so there are some built-in modules in Ballerina that you can use to define these functions. And so how it works is in Ballerina we have an extension mechanism via the compiler. So there are compile extensions that are engaged automatically when we have these special, like when we have annotations that are bound to these functions. So the compiler automatically detects these annotations that are bound to the functions, and they generate the artifact required in that scenario. So for example, here, since we have the AWS Lambda function annotation, it'll automatically check the function signature, validate it, and generate the artifacts required to deploy the function. So then afterwards, basically, it makes it easier for you to deploy anything because all the artifacts are packaged up for you. You don't have to do an extra build step to do that. So it'll be all ready when after you basically build the source code. So I'll directly move into some code and show how this works. So we'll create a new basically workspace. So I'm using VS Code here, and so I'll be basically creating a new source file. So it's a source file with the .bat extension. So the first thing is you import the Lambda extension, AWS Lambda, the Lambda module. And then it's a matter of just writing a function with a specific signature. So let's do like a simple echo function. So the first parameter should be the AWS Lambda context, and the second is an JSON that represents the input. And optionally, you can return a value to symbolize a value returning from function, or you can just return like a null value, nil value in Ballerina, or just don't return anything at all, which has the same effect. And also optionally, you can return an error as well in an error condition. So here, let's just return the same input that we receive. And after that, so this function, you just have to mark it as an AWS Lambda function. That's all that you have to do. And then you build it. So here now the compiler will understand, okay, I have an AWS Lambda annotation with a function. And while it's building the binary, it also create a package, a zip file, which contains the Lambda in that specific format that we can directly use the AWS CLI tooling to directly deploy it. So what you have to fill in is, so there can be multiple functions here. So I just have single one, so it just lists one. So for each function, you have to execute this to deploy it to Lambda. So let's fill in the placeholders here. So I'm just going to call my function echo, and in my code, again, the name is echo. I had to put my AWS role ARN. And that's basically it. So, oops, I had put in the region as well. So now basically it will pick up the zip that was created by the compiler and deploy the Lambda. Yeah, so we see the Lambda was deployed. And now let's do a quick invoke to see whether it's working. Echo, just give a payload. So it must be a JSON value. And we have to give an output file as well. So we see we got the output back. So I can just So yeah, so that's basically a simple way of creating a Lambda from Ballerina. Also, so we'll go into an extended scenario from that of showing you how like some data binding features work with this. So here we just gave a JSON value. So any value that comes here, it'll be contained here. But let's say you want a specific structured value that you already know the format and you want to use that here. That also you can do. Let's say you define a record beforehand. So let's say record, say I'm a person, and I have two fields, name and birth here. So let's say I'm expecting that as a parameter. Actually, just returning something. So you can basically do this also. The runtime basically checks the input value, and by looking at the type we have given here, it automatically converts into that type and basically presents it to the user to use it inside the code, inside the function basically. So let's do like a quick response here. You can say this is the age. Say so we can do something like that. So we are basically returning a string here by calculating the person's age. So a string is again JSON itself. So this should work. Let's see. So let's build our function again. Okay, let's deploy it. Okay. Now it's deployed. Let's invoke it. Now we have to give it in the format that we mentioned. So a name and the birth year. Name is that. Birth year is 1990. Oh, sorry, I just called echo. So yeah, so you see, like we got the response, X age is 30. So it did this basically data binding operation here, and directly from there we can access it inside the function. So in the same way, so we can do this for other event types as well, like in AWS. So like for example, like S3 events and other like API gateway events, and so API gateway requests, and so on. So there's a set of built-in types in the AWS Lambda module that you can use, which you can use directly, or you can just use the JSON as well. The record is easier because then the types are validated, and the fields are already there, so it's easy to work with. So let's go to a quick demo of like how we can interact with S3 as well. So I'll just open up an existing sample and go through the code. So let me explain the high level flow for that. So it's a simple scenario where I do like an integration between AWS S3 and the recognition service. So what I do is I just upload an image to an S3 bucket, do the processing of that using a Lambda, using content recognition, and then I send an email as a result. So I'll be using these three services here. So let's check the code that we're going to use for it. It's a single Lambda function, which basically takes in an S3 event. And what I'm doing is I'm initializing a Amazon Recognition client with the API keys. And basically, from there, I'm just going to detect the labels that I get from the image identification. So that means it will go through the image and identify what are the things that are there. And I'm going to just format it to an HTML table, and I'm going to send it out as an email. So here you can see I just go through this array, the button array. I do a reduce on that and create a single string with the whole table data, which will be the payload of the email. So this is send email is just an email sending function. I'm just using the Gmail connector for it. So all of these API keys and other tokens are provided as environment variables. So in Lambda, you can provide that as part of the function configuration. So I will also give it when I'm creating the function, or you can give it later also in the web console as well. So I'll initialize my variables that I have. And so in the same way, first I build program. You can see here detected the process image function, and now we just simply deploy it. So I already have the command pre-created. So here I'm giving all the environment variables as like the API keys as environment variables here. And at the end, I'm just redirecting the standard output to dev null, because in the output they print out the environment variables. So I don't want to show that here. So if everything goes well, it should just end with an output. Yeah. Okay, so that means the function is deployed. Now, what we have to do is go and configure our S3 bucket to use this function. So this is my bucket, and I would add a notification for all objects created and saying send it to a Lambda function. So I select process image. So that's it. So now it's a matter of uploading a file. Yep. Give me a second. So I'll open up my email as well. Okay. So let's get an image here. So okay. So I upload the image. So ideally now the Lambda should be triggered and the processing should happen, and I should get a mail here. Yeah. So that's what I got. It says, so it was an image with some boats at a lake. So it mentions these labels with the confidence. So in the same way, let's just start without another one. Some mountains. Same thing here. So it detected mountains and so on. So that's an example of like an extended example on how we use the Lambda in Ballerina with S3 and other services. And now let's move into the other section that is of basically creating a workflow with step functions. So step functions is a way of creating like basically a workflow in AWS. So it can, so it's not only limited to interacting with Lambda, but it can directly integrate with other systems in AWS as well. So, and it also supports like suspending its execution as well, like for example, like human interaction. So like for human input and to resume the execution later. So the functionality works by defining a state machine, and the state machine basically drives the workflow on how the steps work. So here we'll create a basic workflow where in the middle some human input is required as well, which simulates a leave approval workflow where a person in a company can send a request asking for leave from that person's superior, and the superior or the lead will get an email uh, with the request, and there we get the option to approve or deny. So this is a place where the workflow stops, and when the lead approves or denies, the workflow continues, and the response will be sent back to the relevant employee. So in the middle, you can update your state in the internal systems and so on in your code as required. So So the diagram shows the high level architecture on how this is defined. So this, as you see in the sequence, it starts with a request from the API gateway. So there'll be an HTTP request that is used to request for the leave, and it goes to the API gateway and it invokes a Lambda. Using the Lambda, we basically start the state machine. So we create an instance of the state machine and we start it. And then the state machine takes over of creating the leave request to be sent to the lead, and an email is sent. And after the email is sent, the approve or deny, again, the links are connected to the API gateway through basically an API request. And that is also, at this point, the state machine is basically suspended. And from there, we depending on the reply from the lead, approve or deny, it again contacts the state machine and resumes its functionality. And again, finally calls the Lambda to communicate the result to the employee. So that's the basic flow. Let's get into the code and see how this works. Let me open up that project quickly. So yeah, I have created some record types here that I'm going to use in the functions. And to simulate the employee and its leads relationship, I'm just creating a simple map here with some hard-coded data. Basically, I'm having employee entries saying what's the lead ID of that employee, and I'm just looking up that map entry from there. So the first request, as I mentioned, that comes from the user hits this request leave function. So here on, I'm using this step functions client module to start an execution on the state machine. So you have to give the state machine ARN, which you can find in the when you create the state machine, either from the web console or from the CLI. So you have to just take it down somewhere. So I'm providing it from a configuration property, so which I get as a environment variable. So I'm going to start the execution from there by giving the initial request information. And so let's quickly look at the state machine. So this is state machine definition. When you invoke the state machine, this is hit, and it basically calls this process leave request Lambda. And also here it does something special. This resource, invoke resource, is basically it's added the wait for task token section, which signifies that a task token should be created and passed on to this resource. So the Lambda function will get that task token, and the state machine execution basically suspends from that point. It resumes only after it takes in the token later by an external call to the state machine. So this is where we stop the execution and we have to call it back with that same token for that specific instance of the state machine to continue. And after, so this is where we get the response from the lead, and it continues and goes to the next step where we process the lead response and communicate it back to the employee. So that's a state machine. So so this is when we send the mail to the lead. So we again send an email with the body by generating a URL with an approve and deny values with the task token. So this URL is coming from the API gateway in AWS. And so depending on whatever we click, that information will be retrieved back to a Lambda here, so to this function. And there we look up the email, so the employee information and the decision, and send a mail to the person. So of course, in a real world scenario, you will update any internal systems with the results and so on. So here we just do the bare minimum. So that's a basic flow. Let's quickly execute, build and deploy this and see. Let me get the command for this. Let me check what do we need for this. Okay. Just get command and update to show that one. Actually, so this is I already have this deployed, so I will not deploy them one by one. Let's see this in action by sending a request to the endpoint. So I'll send this representing this employee 002, which would start the process. So it created this instance and say leave request submitted, and so this should spin up a state machine, and I should have I will get an email eventually. So yeah, it says leave request from Jim. I can approve or deny. So we can quickly go and check our step functions. To see the state machine. workflow. And so this is the state machine. You can see here it's run halfway and it has stopped here. It says it's in progress, it's waiting on the task. And let's see what happens when we approve or deny. Let's say we approve. This should get updated soon. So it got updated. So it basically calls this internal API where I say send task success from our connector, which signals with the task token that this state machine instance should continue. So that's what happened here. And I should get an email back. So I happen to be the employee and the lead as well. So I should get a saying your email was approved. So in the same way, let's do another one. Another. Jane is asking, let's deny her one. And we should get an email saying your one was denied. So likewise. So we can, as you see, we can easily create these workflows and execute them with the system. So it's just a matter of wiring them up with the workflows and the lambdas as required. So that's mainly for the main functionality we have for Lambda and AWS related the serverless features. Let's move on to the Azure functions section as well. So here, so it's basically it follows a similar model. But in Azure Functions, they have a unique model where on how they associate their events to functions through this trigger and bindings support. So you can basically declaratively mention in the code to your parameters and the return values, return types, that these will be the triggers that on how the function will be invoked, and input and output bindings to say how the data flows inwards and goes out. So this is very very convenient when you have a complicated scenario of like when you want to move data between multiple functions and so on. You can directly wire them through the code itself. So this in a complicated scenario, this becomes very powerful. So I'll start with a simple example on like doing a simple hello with the payload. So I'll just override this one. Oh. Yes. So here I'm going to say get the payload and return a string. So in Azure Functions, so it's very flexible in the payload and the return type handling. So here the compile extension figure out what are the payload, the parameters that are given in, and it generates the output artifacts accordingly with the binding information and everything. So yeah, I'm just going to return saying like that. So probably you can do this in a nicer way with a string template. And so then what you have to do is you have to mention how this function is triggered. So I'm going to say this is triggered using an HTTP trigger. An annotation actually. And I'm outputting this again as an HTTP output. Also, you can optionally give other configuration parameters like authentication level and so on here. So I'm going to make it anonymous, so I don't have to pass in authentication information like authentication codes and everything. So then I should be able to directly call it. So let's build this. So here you are presented with the, so we generate the output artifact, this zip file, and we are generating the command to run in order to execute this. So I have my resource group and the function app already. So let's deploy this. Takes a little bit of time, but eventually it will finish the deployment. And I'm actually going to use the VS Code Sure functions, the Sure plugin, where I can list all the functions I have deployed and get the endpoint information and all from there. So which is convenient when you are working with the functions. And also you can get like the log output and all from there as well. So the functions are here. And if you want to get the logs, you can get the logs by connecting the log stream. So it's very useful when you are debugging and doing things. So you can get the function URL here. Let me just say, okay. Yeah, so I got the response. So that's a very simple way of getting a implementing an HTTP request-based function here. So same way, there are many other triggers and bindings like for blobs, queues, and Cosmos DB and everything. So you can use those things to trigger your function and also for input-output bindings as well. So I'll quickly show a more complicated scenario. So it's again an image processing scenario where I do like an OCR scenario. So it first takes in the request that's coming for that's initiated by a user by giving binary data and an email address, and we put it to an intermediary storage, blob storage, and a queue to queue up all the requests. So in order to not to block the request processing. And there's another worker function, which here the process image, which picks up the request from the queue and the storage, blob storage, and process it and put it to a result queue, where another function listens to the queue and sends out email. So here it's optimized in order to not to have bottlenecks in the middle and to optimize the workers and the result publishing as well. So this kind of a scenario, so let's see how we define this in the code by using our input and output bindings and how to chain the functions to get this to work. So let's quickly open up this scenario. So this is the code used for that. So you can see here I'm using the triggers and the input and output binding support a lot here. But at the end, it creates a very short and a very usable code, because we basically express our requirement and the behavior all using these bindings. Like here, I say I'm getting an HTTP trigger input, and I'm going to put my image data in this blob output by giving the blob information. And so I have just route the input data to that blob with the output binding. And also I'm just going to again declarative say I have to put a queue entry also with this queue binding, and I just have to create an entry here and just assign in the value. And the surrounding framework takes care of all the actual operations. So you don't have to worry about creating clients itself, like in this environment. So you don't have to worry about the Azure other services. You have to get the API keys and everything. The services are directly bound to the function. So which makes it very easy to work with. So in the same way, so after I submit a job, so now the request is in the queue and also in the blob with the binary data. So the other function simply picks up from the queue and the blob input. And so after that function, it's directly available in these parameters. So I just have to basically read in that and basically use it in whichever way we want. So here I'm using the Azure CV connector to do the processing, and at the end again I'm using an output binding and putting the result in a queue. And in the same way, another function is listening to that queue, and it gets a result and sends out a mail with the information. So let's see how that happens. So again, just matter of building this. So these environment variables, I have already defined them in the Azure environment in the function app as configuration properties. So I simply have to deploy it. Okay, now monitor the function from here. So the deployment is done, and I should get the function information here. I already have the URL and my email address in this environment variable, so I'm just going to use that. The input is just an image with this content. So it should do OCR on this and send the result. Let's see how it will work. So it got submitted and it gave me a job ID as well. So let's see if I get the response. So since it's the first request, it will take a little bit of time to do the deployment. You can see the status from the log here if you want. Let's do another call anyway. You can see here the log is there. Everything looks okay. Yeah, so we got the response here. So this is the OCR response from here. So now since the function is up and running, it should the subsequent ones should be much more quicker. Yep, as you can see here, we get it instantly with the processing that's happening in the background. So yeah, so that's mainly the code I want to show. That's the complicated scenario. So you can see here with especially with the Azure's this binding support, it's very easy to mix and match the functionality and get a scenario done. And with Ballerina's inbuilt functionality, you don't have to again worry about the deployment aspects, other artifacts, and using another like a build system to get the other artifacts out. But we directly provide those as well. Lastly, as references, you can use our guide to get more information on Lambda and the Azure Functions functionality. It provides a documentation on all the features and also an in-depth explanation on the example scenarios I did. You can refer to these articles. So I provide more, I go into more detail analysis on how things work. So if you're interested, you can check them out as well. So I can take some questions at this moment if there are any. So there was one question on YouTube. One person asked where can I buy the book Beginning Ballerina Programming. So that's actually a book written by myself and Lakmal. So it's there in Amazon. So if you go to Amazon and search for the title, it will be there. So you can get it from, you can order it from there. So yep. Anything that's again related to today's topic or any general questions, we can talk about them now. And of course, if you want to get more involved with Ballerina, you can join our Slack channel that you can find in our website, ballerina.io/community, where we do discussions on the user level and also developer topics as well. We also have a Google group where you can come and post questions there, also have discussions and join in. So another question from YouTube: are there any examples of microservices in Ballerina? So yes, definitely. So Ballerina has rich functionality for creating microservices. So you can find many articles if you search for Ballerina microservices. So just do a internet search, and also in our in Ballerina.io in the website, we have resources on how to write services and the topics that are related to that. So you can go from here. So there are some user guide sections, and also there's a section called Ballerina by example, where it shows how to write services in Ballerina, and also like service clients, and also extended like topics on HTTP functionality, like specific features that are there that you can find. So simply go to Ballerina by example, and you can find all the examples on each aspect there. So likewise. And so, of course, not only HTTP, there are also examples for WebSockets, gRPC, like message brokers like Nets, RabbitMQ, and so on as well. So we have done like a series on like a content series on this topic as well in our first newsletter. So you can go to so our Ballerina community. Go to you can subscribe to the newsletter as well. So we do a monthly newsletter. So go to past newsletter series. So I remember in the first one we do a programming series where we talk about the features of the language, on how it helps the Microsoft development, like network awareness of the language, and so on. So you can go check it out. Actually, yeah, more specifically, the microservice centric one is the second newsletter. So so you can go and check out those topics as well. So I guess yeah, I guess we are out of time now. So again, this recording will be available in the website. You can come and revisit it as well. We'll also publish the samples and the slides also to our repository, and you can check it out separately as well. So again, thank you for joining in. Hope to see you guys again in the next session.